Evaluating expressions. Being able to evaluate expressions is probably the most useful skill from algebra for the real world. We have formulas all around us that we use. An example: find the area of a rectangular shaped room so that we can buy carpet. The formula is area equals length times width. If we are given the length of the room is 20 feet and the width of the room is 10 feet, we can use the formula to find the area. We just plug the numbers in. So we have our formula, area equals length times width, and we substitute. For length, we plug in 20 feet times width, 10 feet, and then we do the math that's there. So 20 times 10 gives us 200, and this is square feet. So you just substitute into the formula to evaluate it. To evaluate expressions, substitute the given values into the variables, and then simplify following order of operations. Here's an example. Evaluate 7 plus 3x when x equals 2. So 7 plus 3x is our formula. X equals 2. This is our given value. So we're going to plug the 2 into the x, preserve the multiplication there. So it's a good idea to plug in with parentheses. So we have 7 plus 3, and I'll use parentheses. That'll show multiplication, and I'll plug in. And then we'll use order of operations to simplify. So we would do the multiplication before we add. So that will be 7 plus 6, which will give us 13. Next, we're going to evaluate 3yz squared plus 1. And here are our given values. X equals 2, y equals 5, and z equals 3. So we're going to plug those values in to our formula or our expression. And we have to preserve the order that's there. Also, when we plug into the variable that has the exponent, we should use parentheses. So we will use parentheses here to show multiplication and for the exponent. So y, we're going to plug in 5. Z, we're going to plug in 3. The z gets the exponent, and we have plus 1. So what did we do with the x? Nothing. We didn't have an x in our expression, so we just ignore it. It's extra information. Now you go with order of operations. Your exponent would be first from what we have. So 3 squared would give us 9. And this is multiplication, so we can take the parentheses off if we want. And multiplication would go before addition. So we have 3 times 5 is 15 times 9 would give us 135, plus 1 will give us 136. Here's a problem in vertical form to evaluate, and we just substitute like normal. We will keep it in vertical form. So keep the 6 plus, you're going to preserve the multiplication there between the 3 and the x. So we'll use a parentheses to substitute for the x. 2. And keep your vertical form. And then we're going to substitute the z. And now you go with order of operations. So we'll work numerator and denominator separately. On the numerator, we would multiply before we add. So 3 times 2 is 6. So we have 6 plus 6 is 12. Divided by 3 is 4. A common way to see and evaluate question is in a table format. Just makes a nice compact way to evaluate the formula for several different values. This one is actually 2 questions. Our formula is here, 5 times parentheses f minus 32 over 9. It's a temperature conversion formula. F is our variable, and first we're going to do it for f equals 41. And then a second question is to reevaluate it for f equals 50. So we will do it for 41. So 5 times, plugging in 41, into the F minus 32. Keep your vertical form there. Work your parentheses first. 41 minus 32 gives us 9. And finish your numerator. It says 45 divided by 9 is 5. So for 41, our answer is 5. And then you just start over. So we're going to use the same formula and we're going to plug in the 50. So we're going to do 5 times 50 minus 32 over 9. Do your parentheses first. 50 minus 32 gives us 18 times the 5 divided by 9. 5 times 18 gives us 90. Divided by 9 gives us 10. So just a different way to see and evaluate question. Evaluating expressions with exponents. Anytime that you evaluate an expression that contains an exponent, you need to substitute with parentheses. You want the new expression to mean the same as the original. An example. Evaluate x squared for x equals negative 5. X squared means x times x. So when you substitute, you want it to be negative 5 times negative 5. For that to happen, you must substitute with parentheses so that the negative can get to the power. So for this problem, we will have to plug in parentheses the negative 5 so that the negative will also get to the exponent. So this will mean 2 copies of negative 5, which will equal 25. You don't see a parentheses on there originally. It's understood that the entire x goes to the power. The parentheses forces the entire x to go to the power. Next, we'll evaluate 3x squared, where x is negative 4. So you're going to keep your multiplication and you have an exponent. So we'll use the 3. We will use parentheses. Negative 4 inside so that the negative will get to the power. And an exponent. And then you go with order of operations. The exponent would go before multiplication. So negative 4 squared means negative 4 times negative 4 gives you a positive 16 times 3 gives us 48. Next, we'll evaluate 2x squared minus 3x minus 5 for x equals negative 4. So we're going to be careful with our signs again. And we have an exponent on there. So keep the 2. We're going to use parentheses. The negative 4 inside. Exponent minus 3 times. You could use a dot or parentheses here. I like parentheses. It keeps the signs in good. And minus 5. Then you go with order of operations. And the exponent's going to go first. So negative 4 squared, negative 4 times negative 4 gives a positive 16 times 2. And next we can do our multiplications. So 2 times 16 will give us 32. Go ahead here and do minus 3 times negative 4 will give us a plus 12 and minus 5. Addition and subtraction go left to right. So it looks like 44 minus 5 gives us 39. We'll have one more of this type of problem. Evaluate b squared minus 4ac. And so we're going to plug in the b has an exponent, so it will have to go in parentheses. And it's going to be a negative 3. The exponent is on the outside. Minus 4 times a, which is negative 1, times c, which is 5. So we've substituted. Then work out your exponent. So it is negative 3 squared. Negative 3 times negative 3 gives you a positive 9. Then we will do the multiplications. So we can do, you can take the negative with you, the 4 if you want, because there's no exponents. So this will give us a positive 4 times 5 will give us 20 plus the 9. 9 plus 20 will give us 29. I just wanted to add one more example. This problem already has the parentheses on it, but you just want to be careful and keep the parentheses and keep the exponent where it is, on the outside of the whole thing. You always want to look closely and see is the exponent outside or the inside. So we're going to keep the parentheses, substitute x, which is 2, minus, substitute y, which is a negative 4. We don't want to lose a sign, so we're going to need a parentheses there. This minus was from the problem. We're plugging in a negative 4 into the y. We have another parentheses, which is the outside one, and keep the exponent. Now, you're going to clean up on the inside. So minus a negative makes plus. So you have 2 plus 4 on the inside, which is 6. And 6 squared means 6 times 6 is 36. But you just have to be really careful how you plug in and keep all of your original notation.